Hey, good morning, students. Today is March 30th. It's our first asynchronous Tuesday of the quarter. Also, we have spring break next week, so let's work on this. Let's get ready for our assessment on Thursday. So I'm going to walk you through the lesson today. You should attempt the whole lesson, as I'll show you, because there are the chance to get these right, and you can see how you did. So this is to be if you need some help through some of these situations. So this first slide 2, look at this graph here. And so this is the graph of a quadratic. And if you know that the point 42 is the vertex, what are 3 other points you know will be part of this graph? So I suggest sketch this out. And what does it mean to have that vertex right there? And so I love this problem because, I know if this is the vertex, it looks like it's opening up like this. And then this one has to hit somewhere over here and go up like this too. So how can I tell other points? Well, remember, when we're looking at this, we know that these points are equidistant from each other. So if this is the vertex for 2, this is the axis of symmetry. The point 3, 3, there has to be another point right over here. So if this is 3, 3, this is 5, 3. Okay? If this point over here is 6, 6, right, this is 1, 2 away. Then I go 1, 2 away this way, and I have the point 2, 6. Then finally, this one looks like it's 1, 2, 3 away. So if I go 3 this way, from 4, 2, it's going to be 5, 2, or 1, 11, right? This would be 4, 11, 5, 11, 6, 11. Right there would be 7, 11. And you might be confused, but look, it's 1, 2, 3, 4, 5, 6, 7. Every 2 squares is 1. So double check that. Go ahead and plug those into your table, right? 2, 6, 5, 3, and 7, 11 are other points you can determine. If you're struggling to find the points, we said draw the axis of symmetry. And so that axis of symmetry right there, right, makes it reflective on each side. So if it's over here, it's going to be the same distance there. Over here, the same distance there, and over there, the same distance to that side. All right? And then it says this quadratic is defined by the function x minus 8, or x squared minus 8x plus 18. All right? What is the y-intercept of the function? Well, in order to find the y-intercept, remember, you solve when x equals 0. So go ahead and try that on your notes. So this is the function f of x equals x squared minus 8x plus 18. We need to find what's f of 0, because that will give us the y-intercept. And if you notice, when we plug 0 in for x, we get 0 squared minus 8 times 0 is 0 plus 18. So f at 0 equals 18. We also, so our y-intercept is going to be the point 0, 18. Also remember, this is that c term in our standard form. That c term will always be the y-intercept, and we'll talk about that a little later if you didn't get it. All right, let's lower this. Let's put this in. What is the y-intercept? The y-intercept is 0, 18. How do you know? Explain your thinking. All right? 3 here. Now I want you to graph these key points. So the vertex is at -1/2, 9, y-intercept at 8, 0, and the roots are at -2 and 1. And then answer this question. Is it the vertex a maximum or a minimum? And what is the equation for the axis of symmetry? So if you haven't tried this out already, pause it and try. All right, let's walk through these answers. So over -1/2 and up 9 would be your vertex. This point 8, 0 is your y-intercept. And then the roots at -2 and 1 are where it intersects the y-axis. That means it needs to be opening down, and it means that our vertex is a maximum. Finally, what's that equation of the line that goes right through our vertex? We call that the axis of symmetry, right? So how could I graph this line? Well, it is the equal to the x value, and so our axis of symmetry is down here at x equals -1/2. So remind yourself, how do you know if a graph is opening up or down? Remember, it's this a value. Is it positive or negative? And so I want you to go ahead and match these with what's opening up and what's opening down. So once you get all these set up, opening up, opening down, you should get this sign that says, great work, you got them all right, and you can move on. All right, and so then here, go ahead and remind yourself, what are the roots? How do you locate the y-intercept, and what is the vertex of a quadratic? All right, so look in your notes, what do those mean? And then go ahead and match them using this idea here. So what you want to do is you want to find a graph, look at it. All right, it looks like the vertex is at -3 or +3, 0. That's also its root, right? So the vertex and the roots are the same on this one. So 3, 0, and the y-intercept's -0 or 0, -9. So I'm looking for 3, 0 for the root. 3, 0 for the root. This one is there, but look, the y-intercept's positive. So it would be this one right here. And take your time, go through these until you have all 18 cards matched correctly. All right? Here, I want you to just talk about these just a little bit. Notice, how do we find the roots? One of the ways we can do that, right, is we just set x minus 4 and x plus 3 equal to 0. And we find that our roots are 4 and -3. And the graph will match that up, right? -3, +4 as our roots. All right, so then on this next matching group, I want you to match these up with its identity, right? So x plus 3, that has a double root at -3. And since it's positive, it opens up. And so let's see, here we are, x plus 3 times x plus 3. If you're struggling, go ahead and open up your Desmos graphing calculator, and you can just type these in and then match the graphs that way as well. This one says -3, -3. Oop, I lied. So this one actually matches. It says I have 0, right? So this is the correct one, right? That goes with it. And look, 2 cards out of 18 match correctly. So walk your way through that until you get all of those correct. And then take some notes, right? Make little sketches that go along with them to help you with your studying. All right, this next one I want you to play with the A and B sliders. So this top one's C, this bottom one's A. To remind you, what does A and B do when we move them up and down? So C moves it up and down the y-intercept, and A either opens it up or down depending on its value. All right, and then you have a chance to answer these questions, what you notice about A and C. So this is how I would use A, right? A determines if the graph is getting wide or narrow. Also, if it's positive, it's opening up. If it's negative, it's opening down. But C, this term back here, right, that y-intercept, really tells you where it intersects on the y-axis. So that one's really helpful in matching up graphs. So take a look here. Here I know that it's going to intersect at -3 and it's opening up. So I'm looking for intersecting at -3 and opening up. And I'm going to take a guess that this is -1, 2, 3. So if I plugged in a 1, I would get back a -4. If I plug in a 1, I get 1 minus 2 minus 3. So I get -2 plus -3 is -5 plus 1 is -4. All right, and you can see I got 2 out of 18 cards matched correctly. Again, if you're stuck, plug these into a graphing calculator and you can match up the graphs that way. This one is a negative, so it's going to open down, and it intersects at -9. And so you're looking for something that opens down that has an intersection point at -9. If you look here, right, this one intersects at -9, but it's opening up. And you have a bunch of different options here. This one's opening down, but it intersects at -9. This one, or +9, +9, +9. So you may have some issues here with S3 and S8, which ones they are. So you're going to just have to double check some of these equations as you go through it. So take your time, make them work, see what happens when you open up or down, shift left or right. If it doesn't have a middle term, it's going to go up and down the axis. So like G6, see how that doesn't go left or right? It doesn't have a middle term. And so that intersects at 9 and opens down because it's negative. And so you can see that one is another one is done for you. So match these up until you get all of them correct. Jot some notes down so that you can compare them and you can use this on the test Thursday. All right, your final task today is looking at generic rectangles. So remind yourself how to multiply them. You're going to need to do this on your text as you're going through this. So get out your notebook and you're going to do a bunch of practicing here. And so you want to grab each of these and you're going to multiply them out and match them up with its factor. So let's start with this one right here. In your notebook, you're going to want to grab one of these, multiply it out. So my generic rectangle is going to be x and minus 3 times x minus 3. And then let's fill in each box. So x times x is x squared. X times negative 3 is negative 3x. X times negative 3, negative 3x. And negative 3 times negative 3, positive 9. And so we add these up. X squared minus 3x plus 9. And what do we get? X squared minus 6x plus 9. So then I go back to my slide. And I find x squared minus 6x plus 9. Boom, 2 cards out of 18 matched correctly. So you have 9 of those to do. Again, look at these patterns that happen here. This one's pretty fun. Notice, oh, let me see if I could find the other one that looks similar. See how this one's identical? Negative x, except for that negative in front. Use what you see, right? If everything else is the same except for this negative in front, all that's going to change is each of these values are going to change from negative to positive or positive to negative. So I'm looking for negative x squared plus 6x minus 9, and I'm looking for that negative x squared plus 6x minus 9. So use the clues that you have there to make this easier on you and understand the math. All right, so watch this video, walk through it, make sure you get 18 out of 18 matched correctly. If you have questions, text your teacher and we can see what we can do to help. So go back through those. Which ones of these are still difficult for you? And that way we can hammer them home during tomorrow's class. All right. Happy mathing.